spaceships. NASA hired us, in fact, to build the International Space Station, the most recent space station, human-tended, even more than human-tended, that crews live on 24/7, 365. So it's up in orbit. It's been there for, as Tara said, for many years. I'm not here to talk about how we built it. I'm here to introduce you to Julian, who just today got his experiment launched by NASA to the International Space Station. Julian was the second winner of a contest called Genes in Space. It was co-founded by Boeing and Mini PCR, and we have in the audience our Mini PCR friends and our other Boeing colleagues, and our New England Biolab partners, and Math for America is the other contest sponsor. And Julian, the contest is open from, from 7th grade to 12th graders, right? It's an annual contest. As a matter of fact, the third contest is still open, so if you have a proposal, they're due in maybe a week or so, and then that contest closes. Julian here was our second winner, right? He got his award maybe last summer, worked on it for several months, was mentored by Harvard and MIT mentors, and brought his experiment to the Cape a week or so ago, and it got launched today. It'll arrive on station in the International Space Station in about 2 or 3 days. And we promised his lab techs, the astronauts on board, would conduct it. That ought to be in about mid-May. And Julian's here to tell you a little bit about the DNA experiment that he designed and is about to be performed on the International Space Station.
Thank you. Thanks a lot. Thanks, guys. I'm super excited to be here today. This was my first launch. This is actually my first time coming to Cape Canaveral, so coming here was super cool. I love all of the rockets. They're just like littered everywhere, like no one even cares. So it's amazing to see. So I'm a biology type of person. I love biology. I love DNA. So I don't know if you can tell, but this squiggly thing here, this is supposed to be DNA. Do you know what DNA is? Can you raise your hand if you know what DNA is? Yeah, okay, good. I've never tried to explain what DNA is to people, so I think that would be hard. I think, can anyone tell me what DNA stands for? Does anyone know that?
Deoxyribonucleic acid.
There you go, oh my god, wow, yeah. Yeah, it's kind of a trivia term, but for the kids, you can bring that back to your teachers. They'll be pretty excited about that if you know it. So what I've been interested in, it has to do with DNA, and it has to do with astronauts. And I came up with this idea early last year, and I've been working on it for about a year with the assistance of a ton of different people. And I haven't tried to explain it like this, but it has to do with a piece of astronauts' DNA that changes when they go to space. You know how if you look at your shoes and at your shoelaces, if you look at your shoelaces, at the tip of your shoelace, there's like a little plastic cap, and it's just like this big, and it protects your shoelaces from fraying. So that's actually kind of similar to something that's on all of our DNA. So in all of our cells, we have chromosomes. Does anyone know how many chromosomes we have in each of our cells? 46 chromosomes. And on the tip of each chromosome, there's a piece of DNA and protein combination type of thing that protects the DNA from getting damaged, just like the plastic on the tip of the shoelace. And it's really important because when the DNA is floating around in our cells like that, there are a ton of different things that can damage it. So that little cap on the tips of the DNA is really important for keeping it safe. So the question is, what happens when those caps, kind of break? And the breaking is specific. It's when the caps get too short or they get too long. And either of those things can be bad. So if you think of when the plastic tip on your shoelace, if it gets too short, that's obvious. What happens, it'll fall off and the shoelace will get screwed up. If it gets too long with the DNA, a lot of bad things can happen. So if you look at these little caps on our DNA on Earth, with elderly people especially, when they get too long or too short, that's been connected to a lot of diseases that people experience. So different problems with your heart, or different problems with your eyes, or your immune system, lots of different things. So NASA is really interested in this, I think I could say. And that's because when astronauts go into space, a lot of the things that they go through when they're floating around and there's radiation coming through and lots of really difficult things, you know, they don't sleep very well. It's really, really difficult to sleep in space. And the food that they eat is great, and NASA works hard on the food, but it also doesn't keep them supplied with a lot of nutrients, so their nutrition is kind of poor. All of these things mean that these little caps on the tips of their DNA, whether we would say the regulation of those caps, so the control over how long they are or how short they are, that gets kind of screwed up in astronauts. So there was an astronaut, a really famous one, a hero of mine, Scott Kelly, and he spent almost a year in space on the International Space Station last year. And that's a long time, that almost set a record. And they measured his caps, we call them telomeres, I should say, these little protective caps we call telomeres. So they measured the telomeres in some of his blood cells before he went to space, and they measured them after. And what they found is that in some of those cells, the telomeres actually got a lot really tiny. So to actually analyze it or to measure it, we need a ton of it. So this machine does it for us. And so when we send it up there and we make copies of telomeres, which we can do because telomeres are made of DNA, they're the caps on our DNA, we can then, you know, use those copies and look at them. So it's pretty cool. Yeah. Any other questions? Yeah. That?
Do you have any speculation as to what might be causing those events?
What might be causing the differences? Yeah. It's an interesting question, and actually, like, the answer to that kind of thing is like something people don't really know, and then, like, you can go down a really deep biochemical rabbit hole with that. But there's really complex machinery in our cells. Like I talked about enzymes, like these little machines. There are tons of those in our cells, and there are tons of them that control these telomeres. And when I mean tons, I mean like hundreds. So they all float around in our cells, and they grab onto these caps, and some of them make them longer, some of them make them shorter, and then some of them control each other. And so it's incredibly complicated, and each of these little machines is controlled by something else in our bodies. So there's signals, there's like electricity, there's also, so almost anything can affect it. So maybe more copies of the enzyme, yeah. Maybe more of the enzyme. So any of those things, you're totally right. Yeah, so that's totally a possibility. And we want to find out with this. So, yeah.
Where do you go to school?
I go to school at Stuyvesant High School in New York City. I have my teacher here, Miss Jessica Quinzer. And I have great teachers at home too, Dr. Nedwick Moore, and all sorts of teachers at home. It's a great school. Yeah?
So, what kind of DNA are you gonna take in the space? Is it from human or from animals? Is it gonna be every day taking blood from humans, or how does it work? This is the first question. The second question
Sure.
is, when the astronauts come back, that length of the protective thing over the DNA, is it reversible or
Yeah.
they get damaged?
Good question. That is like a huge question. That's a main question. So the first question was, wait, I'm sorry. Could you repeat the first question? That was a great second question.
Are you taking blood from astronauts?
Oh, right. Okay, thanks. Yeah. So it's really interesting. This is a first test. So this is the first time something like this has been done. So it's actually kind of difficult to do it with human DNA or mouse DNA or something like that. So what we've actually done is we've created our own DNA, to speak. So it's kind of synthetic DNA in a way. So it has the same sequence as human telomeres. So human telomeres are, like, if you think of like these stars as like the building blocks of DNA, it's the same sequence as we have in our own cells, but we've kind of created it in a synthetic way, just so we know everything that's going on in that too. Yeah. Oh, I'm sorry, I didn't answer your second question. Yeah, so sorry about that, I'll come back to you, but when, like I can use Scott Kelly as an example, the astronaut, when he came back down and his telomeres were longer, after a little bit his telomeres actually shrunk back to normal size, which is something we don't know how that works either. So hopefully we'll find out, but really important.
I have two things. The first thing is could you maybe find like something that like when the astronauts come back, like they can like it's kind of like maybe a shot which like maybe shortens or like makes it a bit longer, like makes their telomeres a bit longer, shorter.
Yeah.
And my second thing is, on that little thing, where is the telomere, like, what is it?
Yeah. Good questions. I'll answer your second one first, just because that's easier to answer. This is really zoomed in right here. Like really, really, really zoomed in. So to see DNA like this, you would have to have a microscope that we don't even have right now. So no one can actually look at DNA this closely. So if you zoom out enough, you would see it actually doesn't look like that anymore. It just looks kind of like a shoelace, just like a long straight line or curvy line. And at the very end of that, there would be like a little blocky part. And for the shot part, that's funny. That's a really good question. A shot. It would be amazing if we could get a shot like that. It really would be. Maybe in the future. I think it would take a lot of work. Maybe you could help me on that. But I'm trying to think of what that would entail right now. But what we've been working on really is trying to find out how these things work or why they happen. And we need to know why they happen before we can figure out how to prevent it. So, yeah. Sorry? I thought about it, basically I started this about a year ago in February last year, and I first tried to think what real scientists, because I'm just a high school student, what real scientists are interested in, so what they think about on a daily basis and the problems that they want to solve. That's the first thing that I thought of, and then when I knew that lots of people were interested in these caps on our DNA, I started reading about those. So I just went on the internet and Wikipedia, and that's where I started, just reading. And I kept reading for months and months and months, and I'm still reading. So, yeah. Anything else? Great, cool. Thanks a lot, guys.